This is First Coast Math Clinic with Lesson 4, Determining if a relation is a function, from Unit 8, Functions. So the goal for this lesson is to determine if a relation, such as the ordered pair, table, mapping rule, or a graph, are functions. So we're going to look at all these four types of relations: ordered pair, table, mapping rule, and graphs, and determine whether or not they're functions. And in the previous lesson, lesson 3 from Unit 8, we talked about functions. We introduced functions and talked about what a function is. Just as a review of that, a function is a relation where each value from the domain is paired with only one value from the range. So we're going to look at this relationship in particular in relationship to ordered pairs, tables, mapping rules, and graphs, and look at what that looks like. So if you're having difficulty determining whether ordered pairs, tables, mapping rules, and graphs are functions, this is a good video to look at. So just a quick review on domain and range. So domain, we know, is the set of all x values in our relation, or our input. Range is going to be the set of all y values in the relation, or our output. All right, let's start with ordered pairs and determine if our ordered pair relationship is or is not a function. Right, so for numbers 1 and 2, we have relations as sets of ordered pairs, and we want to determine if these relations are functions. So if they're functions, each value in our domain, our first value, is going to be paired with exactly one value in our range. So let's start with our domain, right, our x value, and figure out, are any values in our domain paired with multiple values in our range, right? So let's look at that -3 to start with, right? So we know our domain, the first values, and we notice that -3 is paired with 5. So let's draw our mapping rule. And going through this set of ordered pairs, do we notice, is -3 paired with anything else? Well, I notice I've got -3 here, and -3 is paired with 9 as well, right? So I can draw this as my mapping rule. So I've got my domain, -3 paired with a 5 and paired with a 9. Because of this alone, this is not going to be a function, right? I have my value in my domain paired with multiple values in my range. So because of this alone, this is not going to be a function. Let's see if we can find any other reason that this is not going to be a function. All right, we've got 6 here, so 6 is paired with 2. So I'll put 6 in, and 2. 6 is paired with 2. All right, is 6 paired with anything else? Well, I see 6 here, and 6 is also paired with 4. So 6 is paired with 2, 6 is paired with 4. So we've got two sets of values, two values from our domain that are paired with multiple values from our range. -3 is paired with 5 and 9, 6 is paired with 2 and 4. Because of both of these values, this is not going to be a function, right? Let's compare that to the 8. So 8 is paired with 1, and 7 is paired with 1. Now, both 8 and 7 are paired with 1, right? But remember, our relation is a function if each domain is paired with only one value in our range. Each value from our set of x values is paired with only one value from our set of y values, right? Is 8 paired with more than one value? No, 8 is only paired with one value, right? Only paired with that one. 7 is only paired with one value. It's only paired with that one. Compared to the 6 is paired with two values, 2 and 4. -3 is paired with two values, 5 and 9. Okay? We only care about what the x's are paired with, not the y's. All right? So because -3 and 6 are paired with multiple values, this is not a function. Okay? It's not a function because the -3 is paired with two values and the 6 is paired with two values. Now let's look at number 2. All right, so let's do the same thing. So our domain here, our range here, we've got -6, and -6 is paired with 3. And I don't see -6 anywhere else, but we've got a -8, and -8 is paired with a 2. All right, and then we've got a 9. I don't see -8 anywhere else, but we've got a 9. 9 is paired with 3. Now, this 3 from our range, our set of y values, is paired with multiple x values. But remember, we don't care about what the y values are paired with. We care about what the x values are paired with. Our x values can't be paired with multiple y values. It doesn't matter. The y value pairings don't matter, right? Our x values still are only paired with one value. So we still have a function here. Now we've got 10 is paired with 2. So same thing, that 2 is paired with 2 values, still okay. We've got 8, which is paired with 3. Okay, now 3 is paired with 1, 2, 3 values, still a function. And we've got 4, which is paired with 2. 2 is not paired with 1, 2, 3 values. But if you look at each value from our set of x's, right, they're all paired with only one value, right? Each one of these x values, and it's important you see this, has only one line coming off of it. So they're only paired with one value. Because of that, this relation is a function. Again, it doesn't matter that this 3 is paired with multiple x values or this 2 is paired with multiple x values. We care about what the x values are paired with. We're looking at the x values to determine if this is a function or not. Okay? All right, so let's get into some examples involving tables and determine if our tables are functions or not. Right here we've got examples 3 and 4. We've got a set of tables. X is, as we know, our domain. Y is our range. And again, for this to be a function, each value in our domain has to be paired with exactly one value in our range. So do we see any repeating values in our domain? Well, we notice that we've got this 3 here and here, right? And notice, well, 3 is paired with 4 and 3 is paired with 9. Because of that, because 3 is paired with multiple values, this is not a function. All right, what about number 4? Again, X is our domain. Y is our range. Are any values in our X, our domain, paired with more than one value in our range? Well, do we have any repeating values in our domain? Well, we don't have any repeating values in our domain. 1 is only paired with 2. 3 is only paired with 2. 4 is only paired with 3. 5 is only paired with 3, 6 is only paired with 2. Even though you notice the coordinates, the y points repeat. We've got multiple 2s, multiple 3s. Each one of these x values are only paired with one value. 1 is only paired with 2. It's not paired with multiple values. Same with 3, 4, 5, and 6. Because of that, this is a function. Again, if you want to think about this as a mapping rule, that may be the easiest way to think about this, right? If we think about like our x values, right? So I'm just writing our unique x values, our unique y values, and then drawing our mapping rules. So 3 is paired with 4, and 3 is paired with 9, right? So we notice that this point, that 3 is paired with multiple y values. So because of that, it's not a function. But here, our unique x values are 1, 3, 4, 5, 6. Our unique y values are 2 and 3. And it doesn't really matter that we've got x is paired with the same y value. Because the same x value is not paired with multiple y values, there's only one line coming off of each of these x values, this is not going to be a function. I mean, this is a function, excuse me. This is a function. All right, let's look at mapping rules. So mapping rules are probably the easiest to determine if it is a function or not, right? We already have our x and y set up. We know our x is our domain, y is our range. So basically for our mapping rule, if we have one line coming off of the value in our domain, it is going to be a function, right? 1 is only paired with 4. 2 is only paired with 4. 3 is only paired with 6, right? So each of these x values are only paired with one y value. So this is a function. But for number 6, right, if we look at -2 is paired with 1, and -2 is paired with 2. Because of that, because this -2 is paired with multiple y values, it's got 2 lines coming off of it, this is not a function. All right, let's look at some coordinate planes. All right, for 7 and 8, so we've got some sets of ordered pairs we're going to create a graph out of and determine, is the graph a function? So before I do that, I want to determine, well, do these ordered pairs create a function? Are the relations here as an ordered pair a function? So let's just create our mapping rule, right? Our x and y mapping rule, and figure out, is that mapping rule a function? So starting with our x values, you know, the x is the first coordinate. So we've got -2, 0, 1, 2, and 3. And our y coordinates are the second values. So we've got -2, 0, 1, 2, and 3. -2 is paired with -2, 0 and 0, 1 and 1, 2 and 2, and 3 and 3. So if I graph these, this is my x-axis, this is my y-axis, this is my positive direction, negative, positive, negative. So -2, -2 is going to be right here. So it's -2, -2. 0, 0 is right here. 1, 1 is right here. 2, 2 is right here. And 3, 3 is right here. Okay? So if we connect these, we're going to get a line that looks something like this. So determining if this is a function, is each value in our domain, our x coordinate, paired with exactly one value in our range, our y coordinate? Well, yeah, well, I've got only one line coming off of each of these x values, so yes, this is a function. And what about number 8? So let's do the same thing. Let's set up our mapping rule, right? So our unique x values, we've got 4, 2, 1, and 0. So x values again are those first coordinates, 4, 2, 1, 0. The y coordinates are going to be the second values. So we're going to have 4, 2, 1, 0, -1, -2, and -4. So now I'm going to space this out a little bit. So we've got 4 paired with 4, and 4 is paired with -4. 2 is paired with 2, and 2 is paired with -2. 1 is paired with 1, and 1 is paired with -1, and 0 is paired with 0. So probably noticing that from a bunch of these, right? 4 is paired with 4, and -4. This 2 with 2 and -2, and 1 with 1 and -1. This is not going to be a function. Actually, let me write this up here, give myself a little bit of room. All right, so we've got our x values paired with multiple y values. Our x values are repeating. All right, that 4 is paired with 4 and -4, 2 is paired with 2 and -2, 1 is paired with 1 and -1. Because of that, this is not going to be a function. Now let's see what this looks like as a graph, right? So we've got 4, 4. So again, x and y, 1, 2, 3, 4, 1, 2, 3, 4, 2, 2, 1, 1, and 0, 0, 1, -1, 2, -2, and 4, -4. So our graph is going to look something like this, okay? So this is our graph of a function. This is our graph that is not a function. So think about what our graph is going to look like if it's not a function in particular, right? We're going to have repeating x values. So 2, 4, 1, 2, 4, 1. So those x values are going to be repeating, right? So that means we're going to have points that are right on top of each other, right? 1 is here, 2 is here, 4 is here. So these points are going to be right on top of each other. So that allows us to gives us a specific test that we can use to determine if our graph is a function or not. And that's what we want to do. We want to be able to look at our graph and determine, is our graph a function or not? And the test is called the vertical line test. So if a vertical line passes through a graph at more than one point, the graph is not a function. So looking at number 7, if I draw my line, my vertical line to that graph at any point, it's only going to pass through that graph at one point. Okay? But number 8, when I draw that vertical line to that graph, it's going to pass through at multiple points. It passes through at 2 points. Because of that, my vertical line test, that test itself tells me, gives me an easy test to determine whether or not my graph is a function, and I can easily say that this graph is not a function just by looking at this graph and doing my vertical line test. So let's do a couple examples where we look at graphs and we use our vertical line test to determine if our graph is a function or not. All right, so numbers 9, 10, 11, and 12, we want to draw a vertical line and determine if our graph is a function or not. Remember, our vertical line test says that if we draw a vertical line and it passes through at more than one point, the graph is not a function, right? So if I draw my vertical line here, right, it's only passing through one point. Here, no matter where I draw my vertical line to this graph, here, it's only going to pass through one point, so this is going to be a function. Compare that to number 10. If I draw my vertical line here, all right, it's passing through 1, 2 points, so this is not a function. All right, and remember, this is just like the lines that are already there, are just my x and y axis, okay? So x-axis, y-axis, x-axis, y-axis. Number 11, no matter where I draw my vertical line, it's only going to pass through at one point. So this is going to be a function. Compared to number 12, draw my vertical line to this graph, and it passes through at multiple points, right? Now I'm drawing multiple examples. You only need one example. You only need to be able to draw one vertical line that passes through at multiple points for it to not be a function, okay? So this is not a function. Right, so this video is a little bit longer, but I wanted to give you guys a good amount of practice in terms of determining whether or not a relation is or is not a function. I hope this helped you guys do that. If you like this video, leave a like, comment, and subscribe. This was lesson 4, determining if a relation is a function, First Coast Math Clinic.